Right, so we're looking at functions, and here we have the function f of x is equal to 3x plus 1. And we're asked to determine f of 3, the inverse of f of x, the inverse of f of 4. Now f of x, f squared of x, well, this is actually f squared of 2. Okay, alright. So there's something that I gotta explain about this with number 4 and number 5. Alright, so let's start out though with f of 3. Now all this is saying here we have what? An input value of 3 in the f function. And this is the f function. So x represents the input value, okay? Or the input set of input values. So where we have x, we're going to replace x with 3 since 3 is our input value. So this is how we're going to do this. So we're going to have f of replacing x with 3 equals 3 times replacing x again with 3 in this case plus 1. So again replace x here with 3 and x here with 3. This is saying 3 times the input value, and based on what we're given, 3 here is our input value. I'm gonna simplify the right hand side. 3 times 3 is 9 plus 1, and that's gonna give us 10. Okay, now let's look at the next one. Alright, so now we're looking at f inverse of x. Now all this is saying we want the inverse of this. So think about it. We started with x, we multiply by 3 to get 3x, and then we add 1 to get 3x plus 1. Again, started with x, multiply by 3 to get 3x, then add 1. So doing the reverse, alright, start with x, but we're going to do the reverse in terms of what we're doing to x. So we start with x. The last thing we'd have done was to add 1, so we're going to subtract 1. So that's going to be x minus 1. And then the very first thing we'd have done was to multiply by 3. So in this case, we divide by 3, the reverse. And so this is what we call the inverse of f of x. Do you notice, instead of adding 1, we're subtracting 1. Instead of multiplying by 3, we're dividing everything by 3. Alright, now in terms of the structured way of doing this though, we usually typically, let's look at the process of getting this. Alright, we start with f of x, so we're going to change f of x to y. That's the first step, step 1. Change f of x to y. We're assuming that we don't know this. Okay, this is our solution. Assuming that we don't know this. We change f of x to y, then write back this, 3x plus 1. The next step is to interchange y and x. So where we have y, we put x, and where we have x, we put y. Then we're going to make this y the subject. Transposing 1 over, we have x minus 1 equals 3y. We transpose this plus 1 to the left hand side, giving us minus 1. And now we want to get the y isolated, so we have to divide by 3 since we're multiplying by 3. Divided both sides by 3, we'll end up with what? 3 into 3 goes once, and so we have y. And y is equal to x minus 1 over 3. Notice that this y represents what? The original f of x, but this y represents the inverse of f of x. So we're going to write f inverse of x equals x minus 1 over 3. So this is just a process of getting this. Alright, step 1, change the f of x that we're given to y. Then we're going to replace y with x and x with y. And then we're going to make this y the subject, transposing, or we can say subtracting 1 from both sides. So subtracting 1 from both sides, we're left with 3y. Subtracting 1 from here, we have x minus 1. Then, since we have 3y equals x minus 1, we want to get rid of the 3, so we can isolate y. 3 is multiplying y, so we divide both sides by 3. And we end up with y is equal to x minus 1 over 3. Now, this y represents f of x, and we're seeing this y representing the inverse in operation. So we're going to change this to the inverse of f of x and write back this. And this is our inverse. Okay. Originally, I did this explaining that we can just look at it and tell by recognizing start with x, multiply by 3, then add 1. So do it in reverse. The last thing we did, we're going to do first to reverse the process. So it's going minus 1. Starting with x, of course, minus 1. and instead of multiplying by 3 we divide by 3. So it's a quicker way of doing it. Hopefully that was helpful. Alright, so let's look at the very next one, which is to find what? Which is to find the f inverse of 4, or inverse of f of 4. So since we have a function for the inverse, or the inverse function, where x will now be our input, we can replace this x now with the 4, the input value. So we're going to have f inverse, instead of x we're going to put the input 4, equal, again put 4 wherever we have x, over 3, and this will give us what? 4 minus 1 is 3, divided by 3, but the denominator, and we get 1. So f inverse of 4 is equal to 1. All this is saying is that if we were to take this 1, right, and plug it back into the original function given, which is this, we'll actually get the 4. We'll actually get this 4 here. Okay, so let's just check it. If I were to replace this x here 1, f of 1, and 3 will be 3 times 1 plus 1, we're going to get 3 plus 1 gives us 4. So you realize input is 1 and the output is 4. And so when I do the inverse, right, the input was 1 for the original, right? Input was 1 and the output is 4. In this case, what happened? We're seeing the input being 4 and now the reverse, and the output being 1. Okay, so this explains that what this does, it gives us back the input. Alright, it gives us back the input. So it's like this. It's like we have the domain maps to the what? The range values. Alright, and so going from the domain to the range, we use a regular function, and so we inputted what? 1, and we get 4 by using the regular function, which is f of x equals 3x plus 1. Right? When we input 1, it'll be 3 1s, 3 plus 1 is 4. But when we want to go from the range to the domain, reversing the process, we use the inverse function. So we will input 4 not in this, but in the inverse function that we got up earlier, which is this one. Let's try. So put in 4 into this, give us 4 minus 1, which is 3, and 3 divided by 3 is 1. So this, going from the range to the domain, we use the inverse function. Going from the domain to the range, going from the domain to the range, we use the regular function, but going from the range to the domain, we use the inverse function. Hopefully that made sense. Alright, so now let us look at the next one, and the next one we have is f of x. It's f of x. So let's look at that. Now, the original function we're given is f of x being what? 3x plus 1. So f of x is a composite function. What it really means is f goes inside of f. I want to form an expression for this. Now the reason why I say that we want to look at number 5 as well is because this notation here is really the same thing as saying f squared of x. We're really not squaring this expression for f. What we're doing is just simply saying f in f. Okay, so we're going to take the function of f and put it inside of f itself. So let's see how we do that. So the function f is what? 3x plus 1. That's a function of f, right? F of x. So what we're going to do, we're going to take what? The x, replace it with the brackets, and put inside of x, put inside of this function, where x is, the same function for f of x, which is 3x plus 1. So do you notice that we have, this is actually f of x within what? F of x. So f of x in f of x. So it's 3x plus, this is really x, so 3x plus 1. So this is f of x. But where x is, I'm putting f itself again, which is 3x plus 1. Hopefully that makes sense. So this is actually f of x. Or we could say it's f squared of x, same thing. Now we can simplify this to make this look neater. So we say 3 times 3x give us 9x. 3 times 1 give us 3. I'll put back the 1. And this is going to give us 9x plus 4. Now we don't get an x here because 3 times 1 is just 3. There's no x on the 1, there's no x on this 3 outside. So 3 once is just 3. We do not multiply this by 3 because we're using distributive law. We're only multiplying what's outside by what's within the brackets only. And these are like terms, so we can afford to add the 1 plus 3. But this is an unlike term to these. This one has an x, so we'll leave it as that, 9x plus 4. Okay, so we know that f of x is 9x plus 4, which we're really in fact saying that f squared of x is 9x plus 4. Remember, they're the same thing, right? This is the same thing as this. Now we can evaluate. This allows us to evaluate f squared of 2. So this is part, when I did earlier up here is actually part 4, right? This is part 4. And this one now is part 5. So we want to find f of what? F squared of 2. But we know f squared of x is, or f of x, or f of x, yes, is 9x plus 4. So we can replace the x with the input value of 2 and get what? 9 times 2 plus 4 is equal to, this gives us 18, 9 to 18 plus 4, and this gives us 22. Okay, so you understand that. But there's another approach we could have taken. What's the other approach we could have taken? Well, we didn't have to actually go through this process if we were only asked to find this. What we could have done, let's look at an alternative way, right? Alternative method. What we could have done is simply to do this. We have f of 2, right? That's what we want to find, which is the same thing as f squared of 2, right? Let me just write that. This is the same thing, f squared of 2. Same thing. But let's look at it from this perspective. It's easier to work it out from given this here. So let's look at it that way. All right. First of all, what this means is that 2, we go backwards. So 2 goes into the f function, get the value, and then that answer we put into the f functions. We're going this direction. So from 2 goes into f, we evaluate in f of 2 in other words. When we get that answer, we're going to put that answer where? In f. So we're going that way. So let's do that. Let's find f of 2. But in order for us to find f of 2, we need f of x, the function that we're going to put it in, the 2 in. So in order to find f of 2, we need what? F of x. And f of x is what was given to us, right? F of x was given to us as 3x plus 1. So let's write that back. F of x is 3x plus 1. And now we're going to input or replace this x. Replace that x with what? With 2. So it's 3 times 2 plus 1. 3 to 6 plus 1, 7. So this f of 2 here, this f of 2 here is what? 7. Isn't that so? So we can write, let's put back the first f. Let's put back the first f. And the second portion, which is f of 2, we're going to replace f of 2 with what? Well, f of 2 is 7, so we can replace f of 2. Instead of writing f of 2, we write 7 equal to. Now, this is f of 7. This 7 is our input value. So we look for the function that is f of x. And f of x is what? 3x plus 1. So f of 7 is 3 times the x value of 7. In other words, 3 times x plus 1. And x being 7, so it's 3 times 7 plus 1. This gives us 21 plus 1, which gives us 22. And that's our solution. Now, hopefully, this is helpful. Now, you may wonder, what about in a situation where you don't have f of f, But you may have a situation like this. Let's suppose that you're being given something to work out like this. Let's say you have, let's go back, let's use the same f of x, which is equal to 3x plus 1. But now let us introduce g of x being equal to 2x minus 5, for instance. And we want to find f of g of 1. How would we work this out? There are two approaches we could take. We could first find the composite function for f g of x, or f of g of x. Once we find the expression for f g of x, we input 1 into that expression. And the second approach we could take is to find g of 1 first. So we're going to go work backwards, just like f of 2. We work backwards. So f of g, though g is another letter, we're doing the same thing. F g of 1, we find the 1 to the n, which is g of 1 first. So let's find g of 1. Let's try that approach. So in order to find g of 1, we need the expression for what? G of x. So we can input 1 into it. So g of x we know is given to us as 2x minus 5, sorry. I'm going to input 1 where x is. And so it's 2 times 1 minus 5, which gives us 2 times 1 is 2 minus 5, which gives us negative 3. Again, if we put 1 here, 2 ones 2, and 2 minus 5 is negative 3. Okay, so we know that g of 1 is really what? Negative 3, correct? So we can replace this g of 1 with negative 3, because g of 1 worked out to be negative 3. So if I'm going to replace the g of 1 with negative 3, it will look like this. F of, put by the f right here, and in place of g of 1, I put negative 3. So in fact, what I'm trying to find is what? I'm trying to find f of negative 3, because this g of 1 is negative 3. So to find f of negative 3, which is really what? F of g of 1, right? In order for us to find f of negative 3, then we really need to recognize the saying that f of x function is what needed. So we can replace that x with negative 3. We need the f of x function so that we can replace this negative 3. So we can replace this x, sorry, with negative 3. So replacing that x with negative 3, we will get negative 9 plus 1, which gives us negative 8. Okay, so that's how we do that. And I did say there's another approach we could have taken. So alternatively, what could we have done? Well, we could actually, in order for us to find f of g of 1, we could first find f of g of x. To find f of g of x, we're simply going to what? Take the 1 to the n, which is g, and put it in f. To put g in f, we need to write what f is. Remember, recall that f is what? 3x plus 1. This is f. F is 3 times x plus 1. So, replacing f, or should I say, having f, we put 3x plus 1. So replace the x itself with just brackets. So we're going to insert in that bracket where x should be g of x, the function for g of x. And the function for g of x is what? 2x minus 5. So let's input that expression for g of x, which is what? It's right here as well. For g of x is 2x minus 5. So we can input in x 2x minus 5. And then we're going to expand this, which is going to give us 3 to 6x. 3 times 5 is 15. And put back the 1. And so we get 6x. Now put this in the calculator. In fact, the two numbers have different signs, so we subtract and get 14. Which sign will we keep? The negative. There are more negatives than positive. So f of g of x is 6x minus 14. Now we can input the 1 where x is. So it's 6 times 1 minus 14. and this gives us 6 minus 14, and this will give us negative 8. Do you notice that we get the same answer? Right, we get the same answer. Same approach, different approach, same answer. Alright, so now there's one more thing that we got to do with functions. Let's suppose that you were given something like this. Alright, let's suppose that you were given the same two functions, and they, okay, let's go back to this. F of x being 3x plus 1. Okay, it's right here. F of x equals 3x plus 1. I probably can just turn this around and keep that portion. Alright. And let's say they ask you to find f of 0 or some other number plus g of negative 1. How would you write this out? How would you write this out? Well, you find f of 0 first, then you find g of negative 1, and you work out what this operation here is saying. This is saying add. If you were a minus, you do the same thing. Find f of 0, then find g of negative 1, and then you minus them. So whatever sign is here, you do this last. Let's find f of 0. So f of 0, we're calling which function? The f function. So we input in 0 into the f function. So that's going to be 3 times 0, which we know is 0, so that's cancelled off, plus the 1, which gives us 1. So f of 0 is 1. Then we find what? Then we find g of negative 1. So to input negative 1 into g, we call a g function, which is 2x minus 5. So it will be 2 times x minus 5. And where x is, we put the input value of negative 1. This gives us negative 2 minus 5. Bring back negative 5, by the way. Negative 7. So if we go back to what we were asked to do, we were asked to find what? Alright, we were asked to find f of 0 plus g of negative 1. Now what's f of 0? F of 0 is actually 1. So replace this with 1. G of negative 1 is really negative 7. And so we add these two quantities. We add in two numbers with opposite signs. We subtract. We have more negatives than positives, so that's be negative 6. That's our solution. Okay. Now there are other concepts that we could look at with functions. What about when they ask about function being undefined? What would the value of x make a function undefined? So let's look at another function then. Let's suppose that we have something like this. H of x is equal to x plus 1 over 2x minus 5. And they ask you to determine what value of x makes h of x undefined. What value of x makes h of x undefined? How would you do that? Well, this is a rational function, right? Rational because it's in the form of a fraction or ratio. We have the numerator to the denominator. So what's value of x? What value of x? If I put a value of x here, so I'm replacing it here and here as well, which value of x could I put so that this answer becomes undefined? In other words, you divide it by 0. When divided by 0, the result will be undefined. Now, so in other words, what's the value of x that makes this denominator equal to 0? So we can say a function is undefined when the denominator is equal to 0. Alright, so that's the case. A function is undefined when the denominator is equal to 0. So we can say h of x is undefined when the denominator of 2 minus 5 is equal to 0. Alright? When the denominator is equal to 0, then the function is undefined. But this allows us to find the value of x. So we're gonna add a positive 5 to both sides to get rid of this. We have 2x. Add in 5 here, cancel it. Add in 5 here, give us 5. So in other words, we transpose the minus 5 over as positive 5. And then we divide both sides by 2. And so we have x equals 2.5. Alright, or 2.5. So if we put 2.5 here, think about it. If we put 2.5 here where x is, 2 times 2.5 will give us 5. 5 minus 5 gives us 0. So regardless to what the solution on top is, when we divide by 0, when x is 2.5, then divided by 0 would be undefined. So this is the value of x that makes the function undefined. Okay, so you might say, okay, I'm not too sure if I understand that. Well, let's see, look at another one. Okay, let's say give you p of x is equal to 3x minus 4 over x minus 1. What's the value of x that will make this function undefined? Well, what number this x would have to be so that the denominator is equal to 0? You said 1, that's correct. So this function p of x is undefined when x minus 1 equals 0. And you can solve for the value of x by adding 1 to both sides. Adding 1 to negative 1 will give us 0, so that cancels out. Adding 1 to 0 give us 1. In other words, transposing this give us 0 plus 1, which is 1. That's the value of x that makes it undefined. If I give you another one, which is g of x is equal to x minus 2 over 5x minus, or let's put plus this time, 1. This function is undefined when what? 5x plus 1, which is the denominator, is equal to 0. And I can find the value of x that makes this undefined now. Subtracting 1 from both sides, since we have plus 1, so subtracting 1 gives us 5x only on that side, subtracting 1 gives us negative 1. Okay, so we transpose this over, it becomes 0 minus 1, which is minus 1. Then we divide both sides by 5, and this gives us x equals negative 1 over 5. Okay, so hopefully that was helpful. Now, of course, that might not be the hardest one in functions. Let's suppose that you're given something like this. Let's suppose you're given something like this. And you're asked, let's go back to the same type of functions, right? Let's go back to that same h function here that we looked at earlier. And you were asked to find the inverse of that function, h inverse of x. How would you do that? Well, we can't just look at this and probably know what the answer will be unless you probably memorize a certain pattern. Then you figure out, okay, you can actually switch and so forth. But this, following the steps, how would you find the inverse of this function? Here, well, it's the format for the inverse. This is saying h inverse of x. Let's find it. So what we're going to do, we're going to change this h of x. First step is to change the h of x to y. Writing back everything else, we have this. Then we're going to interchange x and y. So y became x, and the x's became y's. Then we're going to solve for y. Now, to do this, it's going to be a little bit weird because we have y's, or y in the numerator and denominator, not just one place. So what we do, we try to get rid of the denominator. Alright? Try to get rid of the denominator. And how we do that? We can multiply this side by what? 2y minus 5. So what happened here? It cancels out, leaving us with just what? Y plus 1. But we can't just do that. We can't just do that. Whatever we do to one side, we must do to the next. We're going to also multiply this side by the 2y minus 5. So I multiply this side by 2y minus 5, and I multiply this side here, sorry, this side here by 2y minus 5. It cancels on this side, leaving us with y plus 1, which was our goal, to get rid of the denominator. And then we can actually distribute the x onto these now. X times 2y give us what? 2yx, or 2xy. And x times 5 give us negative 5x. Now, remember, our goal is to make y the subject, right? Change h of x to y, interchange y with x and x with y, then make y the subject. So we're still on that journey of making y the subject. But we have y in two places. Cancel out this denominator, leaving us with these guys here. So I'm going to try to get the y's together so we can make the y the subject. So I'm going to transpose this y to the other side. And this is not a y term, so I'm going to get this guy over to the other side. Let's do that. Y goes over the other side as what? 2yx or xy, transposing y over become from positive y to a negative y. This negative 5x transpose over as a positive 5x. Then I put about the plus 1. I'm not moving it from this side at all, so it remains the same. So now I have the 2y terms. This allows me to factor out y. So I can factor out y, leaving me with what? 2x minus 1. Okay? And I put about this expression here. So what I just did is to factor out y. In other words, y is only here and not anywhere else in the equation. Okay, so we only have one y in this equation. How do we get that when we have two y's here? Well, we factor out y. We divide this by y. So let's look at it. I divide 2yx. I want to get y out of it, so I divide by y. And that leaves me with what? Just 2x. So you guys weren't seeing this. Okay, so I factor out y, put it outside. So in other words, I'll take 2yx and divide by y, right? And that gives me 2x. So I put 2x in the bracket. I'm also going to take this y and divide by the factor of y, which gives me 1. So that leaves me with the 1 here. So again, this divided by y leaves 2x. This divided by y leaves 1. Because I'm factoring out the y. Now I have y times this give me this. Now to isolate y, I recognize that the 2x minus 1 is multiplying y, so I simply divide to cancel it out. I divide also by the same expression. I was left with y equals 5x plus 1 over 2x minus 1. And now if you notice that this seems like the inverse, right? Okay, so it seems as if just these two guys switched, and that's about it. Alright, but the x remained the same place, so it's like the 5 went up there to become 5x, and the 1 before the x went down go where negative is, so we have negative 1, but these two guys stayed, as you can see. So that's something that I've noticed some students have identified and say, okay, I can probably switch them like that. Alright, would it always work? Who knows? So I want to change y here to the inverse, since that was the ultimate goal. And that's our solution. Now what if we were asked to find h inverse of let's say 3? How would we have done this? Well, if we found this and we were asked to do this as a b portion, then we go back to what the expression is for h inverse of x. We're inputting 3 into the inverse function. This is the inverse function. So it'd be 5 times 3 plus 1 over 2 times 3 minus 1. This gives me 5 3 is 15 plus 1, that's 16. 2 3 6 minus 1 is 5. And this cannot be simplified any further, so I'll leave this as my answer, or we can convert this into a mixed number. 5 3 is 15 plus 1 16, so that will be it. So h inverse of 3 will be equal to 3 1/5. Okay, so hopefully that this was really helpful. And some person may say, okay, why not put one more so I can check to make sure that I really get this concept. Okay, I'm going to put one more, and you're going to try, pause the video, and you can always check the solution. You can always speed up the video, or you can actually just go to the end and see if your solution is the same as mine. If not, then you can just go back and play the entire video. Alright, so let's see how we can actually do another one. Find an inverse function of, let's call this k of x is equal to 5x minus 1 over 2x plus 5. Let's use a different value. Let's use 9 here instead. Let's use 9 here. Based on what I've seen, it seems as if you could just simply switch these guys. Leave these. So we'll get 5x here minus 1 over 2x, and we're gonna have a 9 here. Alright, let's see if it actually works, just switching these guys. So let's see, is the inverse k inverse of x is equal to, let's switch them, these two. So we have 5x minus 1 over 2x. We don't trouble these guys here. and we're going to put the 9 going to come down, so it will be plus 9. Is that the answer though, based on the pattern we have seen? Well, let's check. Let's change this to y. Remember, we're trying to find the inverse. And next we're going to do what? We're going to interchange. So we have x, y we put x, and we have x we put y. Alright, just remember, wherever we have x we put y. So in both places, yes. Wherever we see x we put y. In two places, of course. If there were more y's, we replace them with x's. If there were more x's, we replace all of them too. Now we're going to try to make this y the subject, so we need to get rid of this denominator. So we're going to multiply this side by 2y plus 5. We do to one side, do to the next, of course. But this allows us to get rid of this since we're multiplying. And now we're going to distribute this. So we're going to be x times 2y give us 2 xy. 5 times x give us 5x. And leave us with 9y minus 1. We want the y terms to come together, so we're going to transpose this 9 over to the other side. And then we're going to transpose this 5x over to the other side. But it will become negative though. We're going to actually factor out y. So to factor out y, we're going to divide this 2xy by y. If we divide this by y, the y cancels y, leaving us with 2x. Divide this by the y, give us 9. We're left with negative 5x minus 1. Then we want to isolate this y. Recognize the 2x minus 1 is multiplying it, so we're going to get rid of it by the opposite, division. So this cancels out once, leaving us with y equals negative 5x minus 1 over 2x minus 9. Now, of course, we could try to change this around. Some people don't like to see the negatives, you know, at the beginning. And we have two negative terms here. So we can actually multiply this numerator by a number and multiply this denominator by that same number, and it will still remain true. We call it equivalent fractions. So we can, instead of multiplying by any number, we can just multiply this top by negative 1. So if we multiply this top by negative 1, what happens? This becomes a positive 5x. This becomes a positive 1. This becomes a negative 2x, so I'm going to put it at the end. And this 9 becomes what? Positive 9. Okay, so if we were to compare though, let's see if we were right. But let's go back with this though. Did anything change? Yeah, the answers look totally different. Alright, we see we have a 5x minus 1 here. We don't have that here, and so we can't always work with this. But we can always double check to see if, you know, we went with the way about it the right way. Alright, went about it the right way. We can always double check. Alright, so 9x minus 1, well, sorry, 5x minus 1, we don't have that here in none of these, and so we can just assume that that wouldn't be correct. We could always test them and see, but just wasting time. Alright, but remember to change this to what? The inverse, right? So we're going to change this to the inverse of k of x, and that's going to be equal to negative 5x, but let's use a positive instead. Positive 5x plus 1 over 9 minus 2x. That's going to be our solution. Oh boy, all of this was missing, huh? So again, y be equal to this expression here. What I did, I multiplied the numerator by negative 1, give us 5x plus 1. Multiplying to my negative 1 as well. This becomes positive, this becomes negative. And so changing y to the inverse of k, write back this. So remember, this y represents k of x, and this y represents negative k of x. Hopefully that was helpful.